the test. Can't show it to you on the camera, but I'll show it to you over here. First page, like I told you, is all naming and drawing. Now, unlike the worksheets I gave you guys, I wrote them all out by hand because this is a test. I don't want you to accidentally misread something. So I got them all, they're all typed up or images from, pictures. So basically, you can see everything should be pretty clear. First page, it's all like that. Naming, and of course I'm going to go over these in a second, remind you some of the tricks that you do wrong. Next page, there's going to be, obviously, some like this with the Newman projections, some like these with, enantiomers, diastereomers. There'll be other, problems where you have to draw them at the bottom. And a few questions, but not many. Most of it's problems, okay? And they're almost all represented by this review here, okay? One of the 2 pages of the review. All right, let's go. All right. Let's use a highlighter here. That's it. See if this works. First thing to find is the longest carbon chain, right? So, in a guy like that, it's pretty easy. How many? 5. So that makes him pentane. But he's got a double bond in him, right? Right there. See the double bond? Don't miss that. So basically, he has to take precedence. I might want to name this guy from this side, but I can't, right? I have to go from that side. He takes precedence over other guys. Double bonds do. So I know it's going to end up, the last thing I'm going to write is going to be 2-pentene, right? Now, since I didn't draw it with the... like here, I have it drawn showing the geometric isomerism. You don't have to tell me whether it's trans or cis, all right? However, because notice how it's drawn here, CH, CH, you can't tell if it's cis or trans. So you don't have to say it. But the last thing you should write is 2-pentene. And if this is a 2, you can't have that be a 2 as well. People did that in the last test, okay? Chlorine down here can't be on a 2 and this guy on a 2. He's on a 4, right? So I hope you all wrote 4-chloro 2-pentene, right? That look good there, right? Good. Now, in this one, same thing. I got to find the longest carbon chain. Where's the longest carbon chain? Well, I would do this. Right? See it? There's the longest carbon chain where I've got other stuff coming off of it. Like, for example, I've got this guy coming off, this guy coming off, this guy, and this guy. Got it? Right? Now, are there any double bonds? No. All right, so the last thing I'm going to write is going to be 1, 2, 3, 4, 5, 6, 7. What's the prefix for 7? And that brings up a very important point. There will be people who won't do the basics for this. They think, I understand this. And they'll get bute, prop, hept, guys that aren't normal ones, that we don't use all the time. And most people know pent means 5. Most people know by now, hopefully, meth means 1. Although I do get people who get meth and F backwards. Okay? If you do that, and you consistently do that, think about how that's going to kill you on the test. Every single problem where there's a methyl or an ethyl or a propyl or a butyl, you're going to get that wrong. All right, so what would I call this guy? I got to have the lowest possible numbers. What are going to be given the lowest numbers? It would be 2, 3, 4, 6, or 2, 4. Yeah, it's going to be this way, right? Okay, so I would call this 2, 4, 6, trimethyl, right? 2, 4, 6, trimethyl. And I don't care what order you put them in. 1, 2, 3, ethyl. And the last one we say was heptane? Right, heptane. All right, good enough. Now let's go to number 3 here. This is a cyclo compound. Here it's got an ethyl coming off and a methyl. That should be a CH3, by the way. And it's just to show up there. All right, so I've got an ethyl and a methyl coming off of there, right? Now, in that case, I have to number the lowest possible numbers. I'm not going to call this necessarily 1, 2, 3 and go around clockwise. The numbers would be 1 and 3. All right. Now I don't care which one you put which. All right. But basically, you can call this 1 ethyl, 3 methyl, or 1 methyl, 3 ethyl. All right. And what would the last name be for that guy? No. Cyclopentane. Cyclopentane. It's a cyclo compound, and there's 5 of them. Okay? So we haven't done those in a while. Now this guy shows the geometric isomer. I would expect you to tell me this time that this is what is that? Trans. Okay. And, of course, it's trans-2-butene, correct? I don't have a whole lot of other junk on there, but I could. All right. Let's go to number 5. Which I guess is this one. Oh, over here, 5. Okay. This is in what conformation? And by the way, first, there's 3 answers to this, and people get the things mixed up. What's the name of that compound? And the answer is not chair. What's the name of that compound? Cyclohexane is the name of the compound. That's the UPAC name for the compound. What conformation is it in? Chair. Chair, not boat. Boat would have the 2 ends up like this. Okay? This one has one end down and the one end up. So that's the name, that's the conformation. Is this the stable conformation or the unstable one? Stable. And let me ask you one last question here. What do we call these guys that are sticking straight up or straight down? What kind of hydrogens are they? Yeah, you've probably forgotten about that. As opposed to the ones that are sticking out, okay? Like these guys that are sticking out. What would you call those? Don't remember. Look it up. Axial and equatorial hydrogens, okay? You have to know that, okay? And you have to know the stability, you have to know the name, you have to know the conformation, and you have to be able to identify which conformation it is, okay? You don't have axial or equatorial necessarily in the boat conformation. You have them in the chair, because the boat has a slightly different arrangement. All right, let's go to this guy. We just got these yesterday. All right, couple of things about these. You have to know both ways to name him. Yes, everybody should be able to name this guy 1,2-dimethyl, 1,2-dimethyl benzene, correct? All right, or 1,3-dimethyl or 1,4-dimethyl, right? So 1, 2, 1, 3, or 1, 4. But you should also know that this guy is what? Orthoxylene, not orthobenzene. People do that all the time. It's orthoxylene, metaxylene, and paraxylene. Xylene meaning dimethylbenzene. That's what the word means. What's the common name for just a methylbenzene? These are the common names I've given you. Now, and you don't realize this because they're not common to you, but they're common to any organic chemistry teacher or any organic chemistry student. You're going to use these compounds. Toluene is another one. Toluene would just be methylbenzene, and that's the other common name you have to know for these guys. All right, let's take a look at this guy here. Let's use this one here. I mean, the RNS configurations, I do have to be able to do those. And I don't have, we kind of spend the most time on that. However, let me just show you the tricks real quickly. I want to compare A to these other guys. What's a real easy way to get the answer to this? Start at the same guy and draw your circle, see what you run into. BrCH3, BrCH3H. BrCH3H. Top halves are the same, aren't they? BrHCH3, BrCH3H. Top halves are not the same. What do we call a guy like that? Diastereomer. Okay. All right, so that's how you can do them quickly. Let's talk. I don't have time to do, we're running out of time here. I want to be able to do the guys over here. Let's talk about how I would do the RRS. If you take the lowest priority bond, okay? The highest priority bond, let's just do the priorities for this guy right here. He's 1, right? He's the heaviest guy. Now, I've got carbon here and carbon here, but this guy takes precedence because he's bound to other things, like a bromine, heavier than the hydrogen. So he's 2. He's 3, and he would be 4. Now, the problem with this guy is, that 4, remember what this Fisher projection means. In a Fisher projection, this means the wedges are coming out at you, and this guy's going back in, right? So right now, I've got that lowest priority bond coming out at me. Whenever I draw 1, 2, 3, it's going to be the exact opposite, because I really have to look at it from behind. So when I go 1, 2, 3, and it looks like S, what is it really? R. Okay, so it's really R. So that's how you do those. Again, I don't have time to do every single one of these, but that's how you do them. And there's both the trick, tell if their enantiomers, diastereomers are identical, and there's also the RRS for that. Now, to do these guys over here, and the camera can't really follow me over here for this one, the same basic idea. I would assign the priorities. I'll use a different color over here. Who's heaviest? Iodine, right? 1, 2, 3, 4. Now, that's an easy one. Why is that easy? Because he's going back into the board, right? Since he's going back into the board, 1, 2, 3, what am I drawing? R. Okay. this guy right here, 1, 2, 3, 4. I got to get underneath. Look up. 1 is here. 2 is there. What am I drawing? What do you guys call it? It is. And what do we say this guy was? So that makes, if they're both R, what does that make it? Identical. All right. Now, if this guy's an alkene and he's C22, okay? I guess I get a 3 board here. Hold on a second. If he's C22 and he's an alkene, what does the H have to be? 44. Because for an alkene, it's CnH2n. But now the next one I ask you, say I've got an alkane with C20, what does the H have to be? 42, because he's CnH2n plus 2. And I know if you're thinking about, well, there are some guys who are the same, I will make it clear which ones are which. All right? Because I think alkenes and cycloalkanes would be the same. Now you have to know that. Okay, that's all back from the first day of the notes I gave you on this. I gave it to you in a chart form. All right, and lastly, I skipped over structural isomers. I want to do those, and I want to do this guy over here. Let's do this guy over here first. How would I draw that compound? Here he is. So let's see it on the video. C2H5 up here. H and CH3. And I've got H, CH3, and CH3. Now, there's a couple of ways to think about this, okay? This dot and this circle are 2 carbons. That's the dot, that's the circle. So I just take them one at a time. This dot, we'll call him the dot. CH3, C2H5, H. I'll put my C2H5 on the same line so I don't screw it up. There's my C2H5. There's my H. There's my CH3 coming off the dot. Coming off the circle, CH3, CH3H. Here's my CH3. Here's my other CH3. Here's my H. What compound do I have, naming them correctly? 2,3-dimethyl. 1, 2, 3, 4, 5. Pentane. Got it? Good. All right. And if I were doing them backwards, say, for example, I give you a guy like this, and I said I point at that arrow. I want to know how to draw him, the Newman projection. Same thing. You do it backwards. That's your dot, that's your circle, that's what you draw. Okay? And you would do that. You have H coming off, H, CH3, H, and H. Okay, so H, H, and CH3 on that guy. For this guy, it would be 2 CH3s and an H. Okay. All right. Last one to do. We only have a couple minutes left. The structural isomers of C6H14. All right. I would do them this way. First, and again, I'm going to leave out the H's. You can't. You got to fill them all in. But I'm going to leave out and again, not necessarily the H, just the dashes around. In other words, I'll do 1. Do 1, and then we'll look like this. 1, 2, 3, 4, 5, 6. And you name him. He's called hexane. You have a double period tomorrow. There's no reason we won't get finished in time. All right. Then I'm going to shorten him up by 1. And I'm going to put that methyl wherever I can. Can I put the methyl at the end? No, that's just going to make the chain longer. So I'll put 1 up here. Again, I'm going to leave out the H's then. I can move him around to lots of places. Actually, not as many as you might think. And people will do this. They'll call those 3 different guys. Are they? No. These 2 are the same. So this guy's wrong. All right? So I've shortened them up. These 3 are the only way I could do those. I'll shorten them 1 more. What can I do now? I'll have 2 methyls to go around, right? Got it? Did you get that one? Oh, yeah, sorry. I have 2 methyls to go on there, right? Okay. And can I do this? No, that's the same thing. But can I do this? So, do you have 1, 2, 3, 4, 5 of these? Can I get an ethyl out of that? Can I do this? Is that going to be 1? No. It's just going to make the chain long. Got it? All right, last thing before the bell rings. What about the essay short answer? I don't have to call them essays, short answer questions. They will be on the 3 pages I gave you, 3 articles. The flutamide one about stereoisomers and enantiomers. The chiral quest one about modern day drugs that are chiral. And the trans fats, okay? Okay? All right. So look those over as well.